Everybody's listening.
All right, here we go. So this is 7.1. I want to go through. I'm going to have everybody has to do today. You got to get at least one green check on the 7.1 assignment. So this is stuff we talked about 2 days ago. Is that right? 2 days ago. So let's hit this one more time. I want to make sure everybody is up to speed on this because the next test it's coming up this week. And it's really small. It's not going to be very hard. It's going to be a good opportunity to get a good score on a test, but it's mostly this kind of stuff, exactly this. So let's talk about this problem.
That you make it equal to 0.
Say it again.
That you make it equal to 0.
Right. So we're trying to find the zeros of this thing, right? So we want to set this equal to 0 and solve. Whoops. Set this equal to 0 and solve. And what's our thinking on this, right? So this normally would be one we'd split in half, right? It's got 4 terms, and so we try to solve this thing by factoring, by grouping. It's not going to work this time, but it's a good idea, right? And maybe we could even see why we could look at it and say, okay, not going to work. Let's just try it real quick. If I split this in half, what's going to be the greatest common factor of the first group? X squared. Yeah, because there's no number that divides into both 12 and 25, right? So it's just going to be a plain old x squared. What's that leave behind if I divide out the x squared? So what's 12x cubed divided by x squared? 12x. And what's 25x squared divided by x squared? 25. So there's the leftover, right? So now from group 2, we'd have to get the same leftover, right? But that's not going to work, is it?
No.
Not going to work at all because there's nothing I could put out front of this. What times 12x is negative 4x? Already we got problems, don't we? Right? Mm-hmm. So it's not going to work. What if I even tried to do this a little differently? What if I tried to do this like... What if I tried to do this by taking out the greatest common factor, of negative 4? And then seeing what we got left over. That would just be an x plus 3. Does that make sense? Either way, it's not going to work, right? I'm not going to get a common factor between those two, am I? Right? So factoring by grouping doesn't work. So we got to try something else. So what could we do? Well, that's where the rational root theorem comes in. So if the polynomial has integer coefficients, which everyone we've dealt with does, right? All the coefficients are not fractions, and they're not square roots or anything. They're just integers. Then if there is a non-square root answer, if there's a rational answer that we could write as either a fraction or an integer, then it has to be, the 0 has to be built from factors of the constant divided by factors of the leading coefficient, right? So let's see what that might look like. So those factors will be blue and these factors will be red. So the only possibilities would be values of x, where on the top we would have factors of 12, which would be what? Starting from the smallest and moving to the biggest. Okay, so we get plus or minus 1, plus or minus
2, 3, 4, 6, 12.
Divided by potentially same stuff, right? So on the bottom, I won't put the plus or minus signs on the bottom because we've already got them on the top. But the denominator could be 1, or it could be 2, 3, 4, 6, or 12. Well, that is a ton of possibilities. There's no way you're going to try all those, and you won't have to. We always want to start with the low-hanging fruit here. We're going to do the easy stuff first, and then we'll work our way up to the harder stuff if we need to, right? So we'll always assume that the bottom has a denominator of 1 to begin with, because that makes all of these answers divided by 1 is just integers, right? So let's make a list, and we'll just work down the list of all the possible values of x that we could try to see if they work. So we get 1, negative 1, 2, negative 2, 3, negative 3, 4, negative 4, not 5, 6, -6, 12, -12, and then what? So that's all the possibilities with 1 on the bottom. Then we'd move up and try 2 on the bottom. If we had to keep going, we could do 1/2, -1/2. 2 over 2 is already on there, that's 1. 3/2, -3/2, etc. But we're not going to get there. You'll never get that far. It'll always be something that you'll get pretty quickly. I'm not going to do that to you where you have to work your way down a huge list like that, right? You get the idea though? We've got this list, and we're just going to try these one at a time until we get one that works, right? Once we get one that works though, we're in great shape, because if I could factor this is cubic, right? So if I could find a 0 that worked, that would be like factoring out x minus that 0. So let's just say, for example, that 3 worked, right? Then you see that that would break this up into, it would take this 12x cubed plus 25x squared minus 4x minus 12 and break it up into x minus 3 times whatever's left over. What can you tell me about what's left over? What's going to be the degree of that factor? If this is 1 and that was 3, it's going to be squared, isn't it? So we're going to get something, we're going to get a quadratic factor here. So when I set that equal to 0, that's easy. You did about 1 billion of those in Module 3, right? Worst case scenario, you just use the quadratic formula, right? So if we can just find one of them, we're essentially done with the problem, right? Okay, so let's see if we can find one. Okay, so here's where we're gonna make that template, and I want you to see how this template works. You don't have to do this. You could just do regular synthetic division, but this will cut down your time a little bit, right? So what are the coefficients that are going to go in my template?
12.
12.
-4. -12.
Okay, and now normally with synthetic division, we'd put the bar down here and the remainder box would go under the 12, right? So we're going to go ahead and I'm just going to make a vertical line here that separates off. This will be the remainder column, right? And then out front, we're just going to pick values, and we're going to work through the whole process. We're going to do the abbreviated, kind of the shortcut synthetic division process. So what if we take a 1, for example? So what would be the numbers if I were going to do synthetic division? I would drop the 12 down below the line, right? So we're just going to write the numbers in here that would end up below the line. So we get a 12, and then 12 gets multiplied by 1, right? 1 times 12 is 12, plus 25 is 37. So that would be the next number below the line, right? So that's one we'll write. 37 times 1 is 37. So this isn't going to work, is it? Can you already see this isn't going to work if we keep going? We're not going to get 0 there.
Nope.
So we'll just cancel that one off and start over. So -1. Bring down the 12. Okay, this is a little bit better, isn't it? Because -1 times 12 is -12, so we're making that number smaller, right? What's -12 plus 25? -12
Oh, okay.
times 1 is
Wouldn't it be
-12.
17?
13, there we go.
13.
-12 plus 25 is 13. -13 and -4, it's not quite still going to work, is it? I get -17, and that gives me 17 plus -12 is not 0, but it got closer, right? So that one's done. Okay, let's move down some more. Maybe I'll change color so we can see the rows better. So next one we'll try, so we canceled those guys off, right? So now we'll try a 2. So I bring down the 12. 12 times 2 is 24. 24 plus 20, that's way too big. It's not going to work,
-2.
right? Nothing's going to happen there that's going to be good. Just going to get big numbers. So we'll try a -2. -2 times 12. -24 plus 25. -1. -2 times -1 is 2 plus -4. -2. That still didn't work, did it? Got to keep going. Okay, you think 3 is going to work?
No.
Probably not. Let's try -3. You're already kind of seeing a pattern, aren't you? So we'll bring down the 12. 12 times -3. -36 plus 25.
-11.
-11. Wow, that's not going to work either, is it?
Oh my gosh.
What's going on here? So negative 3 times negative 11 is 33 plus, so that's not working.
Do negative 6.
It's negative 6, you think, huh?
Yeah.
All right, we'll try it. The thing is, honestly, I'd like to say there is, but there isn't. This is the fastest way to do it.
Do you know the number?
I don't.
Okay,
I don't
negative
know the
6.
number.
That's my guess.
Your guess?
Negative 6.
You really think it's gonna work?
Yeah.
Okay, we'll try it.
Negative 5.
Negative 5 isn't one on our list.
Oh my god.
So negative 6 was on our list. If I bring down the 12, well, that seems like that's gonna be way off.
It's negative 8. It's negative 4.
Okay, we'll try it. We'll try it. So I get negative 72.
I regret my decision.
Do you?
Yeah.
Okay. Yeah, I think it's gonna be 4.
Told you. Well, I skipped it.
Yes.
I said like 8 times.
All right, let's try negative 4.
Your voice don't matter.
Justin, you think negative 4? Have you done this? Did you do it?
No, I'm just
Oh, okay.
saying.
All right. So negative 4, let's try that. We bring down the 12. Negative 4 times 12 is negative 48 plus 25 is negative 23, right? No. So how is this going to work? That's not going to work either.
Wait, how did you get negative 23?
Why not?
Negative 4
48
times 12.
Is negative 48.
plus 23. Plus 25 is negative 23.
Oh, I missed the 4.
I must have screwed something up because these are just getting further away.
You
Did I do
messed
this?
up.
Did I do one of these wrong at the beginning? Negative 2, did I do that wrong? Negative 24, negative 1, 2.
It would be 1. Not negative 1. It'd be positive 1.
It would, but it's still not gonna make any difference.
It's
Oh,
negative
yeah, it
12.
would. It
Yeah.
would. That one's gonna work. You're right.
Simple mistakes, Oya.
Yeah, I know it. I know it. Man, who's teaching this class? Okay, so here we go. Let's try the negative 2. I think that should have been the winner. So there's my 12. Negative 2 times 12 is negative 24 plus 25 is positive 1. There we go. Negative 2 times positive 1 is negative 2 plus negative 4.
Is
Negative 6. Negative 2 times negative 6 is
12.
12 plus negative 12 is 0.
Okay.
You got it. All right. Pretty good start.
Star.
That's a terrible star. It's a terrible star. All right.
Gotta erase the evidence.
Erase the evidence, exactly. It's taped though, so it's on video. I'll never get rid of it. So then we know that. So what's that tell us? We know that negative 2. Hold on, listen please. So we know negative 2 is going to be 1, 0, right?
Yes.
That leaves us behind with this, right? This is the factor that's left behind. Remember, this is the remainder is 0. What do those numbers mean again?
They're the
Coefficients. So that's the constant,
x
right?
and x squared.
Coefficient of x squared. So look what we're doing then. So we've got the equation. If we write this as a quadratic equation then, we've got 12x squared plus x minus 6 equals 0, right? Okay. So then how are we going to solve that? Now we're in algebra mode here. We're in module 3 mode. We've got to solve a quadratic equation. We could try to factor it. We could use bottoms up, but what could we do instead maybe?
Divided by x plus 2.
What do I do? Oh, you were completing the square?
Yeah.
Okay, let's not.
What?
Let's just
Okay,
do
but
this.
the real zeros. X plus 2 because you have negative 2 there.
Let's just do this.
Well, that's too difficult.
No, this isn't difficult. It's just a matter of plugging in some numbers and simplifying an answer, right? Okay, does everybody see where we are? Everyone up here, please. I need everybody's focus. I got some other things going on. So we got to decide. We could do bottoms up. It's going to work, by the way, because we want to find numbers that multiply to 12 times negative 6, which is negative 72. Are there magic numbers that multiply to negative 72 and add to 1? There are.
8 and 9.
8 and 9 and negative 8 would work. So we could do bottoms up. It would be fine. That's a possibility. But we could also, and here's what I want you to see, we could also just plug stuff into the quadratic formula because this is a quadratic equation in standard form, right? It's in the form ax squared plus bx plus c equals 0. Now I want you to see something here though. What's the value of a?
12.
What's the value of b?
1, 8 or 6.
What's the value of c? Well, what do you know? There they are, right? When you end up with just 3 coefficients, those are a, b, and c, right? It's a quadratic factor, and those end up being the values of a, b, and c. So if you want to use the quadratic formula, there are a, b, and c. So we would just end up getting x equals negative b, so negative 1, plus or minus the square root of b squared, so that's 1, right? Minus 4 times a, which is 12, times c, which is negative 6, all divided by 2 times a, which is 2 times 12, which is 24, right? Okay, so then what are we going to get inside here? Let's see if we can turn all this into a number. So if I've got negative 4 times 12 times negative 6, well, negative times negative is positive, right? And what's that going to be? What's 12 times 6 is 72, right? If I multiply something by 4, I just double it twice. So what's 72 doubled?
144.
Doubled again.
288.
288. So this is 288 plus 1. So everything in here is just going to be 289, right? You guys getting this?
Yeah.
Okay. So all this stuff becomes the square root of 289, which is 17. 289 is a perfect square. So then look what we end up getting for our answers. We get x equals negative 1 plus or minus 17 over 24. So all we have to do is take into account the plus sign and simplify, reduce the fraction. So if we take the plus, we get x equals negative 1 plus 17 is what? 16 over 24.
Which is 4 over 6.
No.
Which is, I don't know,
We can do better than that. 4 over 6, but we can go lower.
2 over 3.
2 over 3.
I was slowly reducing.
Okay, so there's one other solution. If we take the minus sign, we get negative 1 minus 17 is what? So what's negative 18/24 reduced to?
1/2.
No.
Gosh darn it. 9 over. Oh wait. That's stuff. Maybe 8 over.
3 over 4. Because 6 goes into 18 3 times, goes into 24 4 times.
Did you say 0 over 4?
So what would our answers then are just 2/3, negative 3/4, and negative 2. So in Moodle, all I would input up here is that. So if this is the answer box, we got negative 2. What were the other two?
There's
2/3,
And then 3.
negative 3/4.
Yeah.
Okay, that's it. Got it?
Yeah.
Go. You gotta do at least one from 7-1. Go.
Gotta take the test instead.
Yeah, but you gotta do one from 7-1 first. At least one. I gotta see one green check from everybody. What's that? Yeah, go ahead. $5, Ariel gets one that doesn't have Wi-Fi.
I don't have cash on me, sorry.
Yeah.
It either doesn't have Wi-Fi or doesn't let me log in.
Yeah.
Dude, that happened to me, like, constantly. It really do. You should just get like a router and just your room.
Yeah.
Can you turn this thing on? What happens?
It's in physics. Yeah, we're measuring, I'll tell you what we're doing. We're measuring,
Is physics hard?
I don't know
it's mathematical, but you can do it. You gotta do well in this class, first step. What we're measuring here, I've got sensors that'll measure at the same time the speed of the cart and the force that's applied to the rubber band to make it move. And we'll compare the two, and we've got a really interesting relationship between the two. It explains about impulse and momentum.
See, I'd rather take this because this seems more interesting than honors
It's
bio.
very
too.
interesting. Love physics. Physics is the best.
Bio is so easy. I get it. I want some challenging, so I don't know. I'm still debating. It's worth it.
7.1? Oh, you already did? Oh, you're good then. You can do whatever you want then.
Because I did this like 2 years ago in space.
Oh, okay. So this is easy for you.
Oya, you owe me $5.
It works?
No.
Oh, so that was, see, my bet was that it wouldn't work. So you owe me $5. Yeah.
Do you think I'll pass the class if I did that? Considering what I do in this class.
Well, it's the thing that would be tough, the part in there there's a lot of math. There's a lot of math.
I'm fine with math, I just have to get it.
Yeah, it's there. Like if you're taking college algebra, people get by with that. But we do some trig in there, so I have to teach you guys some trig at the start of the year.
Okay.
You get one? All right.
I'll do it and see what happens.
Yeah, I would give it a try. You'd love it. I think you would like it a lot. I really do.
Okay.
And you'd work hard at it, so I think you'd be okay.
Okay.
Yeah.
And how long is the test to the placement test?
What's going on? That's what I thought. Yeah.
Sit there,
Uh-huh.
enjoying life, you know?
Mm-hmm.
How long is the placement test?
How much is what?
The placement test to do on a trip, like pre-calc.
I don't even know. It's gonna be a different one. It's Mrs. Jones thing. I don't have anything to do with it.
Is it just algebra skills?